All right. So this question says, diagram below shows a container of length 3A that John made to store cooking oil. The cross section of the container is an equilateral triangle of H. So what we want to do is to, in order to have a clearer vision as we go forward, you want to highlight some stuff as soon as you have them. For example, let me move this. So for example, we want to note that we were told here that the triangle, one side is A and it is equilateral, which means that they're all the same length. So this is A, that is A, as well as all of that is A. We want to note that so that it will make, when we're ready to probe the questions, a lot easier because we would have information. So all of that is A right there. All right, let's look further. It says an enlarged diagram of the triangular cross-section of the container is shown. So there it is, an enlarged diagram of the triangular cross-section. And we want to make note that this is A as well as this is A, even though they did not say it again, but we were already told. So we want to make sure that we remember that these, you know, that is A, that is A, and that is A, because it's an equilateral triangle. All right, let's see what they really want. First question says, find the perpendicular height H in terms of A. Now, look at this question. We were asked to find the perpendicular height, and they did say in terms of A. So definitely, we will know, we would realize here that we're not going to find a value for it, right? We're going to get an expression with A in it. So let's go back at the diagram to see what information we have. So we could look at this. We want to note here that a very important thing here is this. That's a right angle triangle right there, right? So the height H would have been all of this distance coming down, and it would have hit this base at 90 degrees. And that is going to give us that clue to help us just to move on and to easily wrap ourselves around the idea. We're going to employ Pythagoras theorem here because we're having a right angle triangle and we have some expressions for the sides. What I want us to remember that whenever we have an equilateral triangle and the height is coming through like this, it will hit the base such that this length is the same size as this length. And that is what we're going to be using now to go on, because the height of this triangle, because of the special nature of it, when it hits the base, it's going to divide the length into two equal pieces. So the distance from here to here is equal to the distance from right here going to the other side. So we're going to be using that to help us right now. What that says about labeling, we can say that this is half A and this is half of A. And together, when you add them, you would have got just 1A. So you're seeing here where we have to employ that thinking based on what we know about the equilateral triangle and a perpendicular height. It always cut the side, the other side, the base of it, in half. The Pythagoras theory now will point out the fact that this is the longest side because I'm focusing now on this. Let me focus on the triangle, focusing on just this side, just like this. So we're focusing on just one of them. So you're focusing on just one of them because we are now going to use this to help us. Remember, it's H we want to find, but you want to set up the idea first that A square, which is the longest side square, is equal to H square, which is a short side, plus the other short side square. Ideas. So I don't want you to worry about anything. You're applying yourself. The response must be given in A. That's what they said. So we want to find h. So basically then, let's flesh out this. So basically this is a square is equal to h square, right? Plus 1/4 a square. Now, remember though, I'm squaring the half a square, which means that if I should quickly do it here, half a times half a will give us 1/4 and then a square. So that's how we got this part here, right? That's how we got that part. When you square half a, you end up with 1/4 a square. So what we're going to do now is to gather everything on one side, leaving that h. So a square, then we're going to subtract, yeah? We're going to subtract quarter a square from both sides. So it's going to be subtracted from this side. And we're left with h square. So basically, some people might say you bring it across and change the sign. We kind of subtract it from both sides. Now, I want us to think, though, if I have 1 a square and a minus quarter a square from it, I am left with 3/4 a square. Yeah? So I want us to think about that. If I have 1 a square and I take quarter a square from it, I am left with 3/4 a square. So now that's what we have for the height. Now what we're going to do, well, this is not yet the height. We need to take the square root. So now we're going to take the square root, yeah, of both sides. And this is what is going to happen. When you take the square root of the h square, you're left with h, fine. But what happened here, the square root of 3 is just the square root of 3. But if you take the square root of a, you're going to be left a square, you're going to be left with a. And the square root of 4 is 2. So basically, what we really have here is root 3/2a. All right? So if you want to put it like that, that is h. So we could write h anywhere we want to write it. So h is equal to root 3/2 with an a behind it, just like that. It did say, let's just write this here. So the height when we're done was the root of 3/2 with a. Let's pay attention again to what's going on. It says now, show that the area of the triangular cross-section in terms of a, so it is in terms of a again, we're not finding any value, is the root of 3/4 a square. You notice it's 1 mark for it. And they're telling you that the root of 3/4, depending on how you calculated it, if you get 0.433, it's fine. In other words, then they are saying that you could have got 0.4333 a square, and it still means the same thing as that. That's what they're saying. So depending on how you work, you look out for that. Now, key things that we have to focus on here is show that the area of the triangular cross-section, hold on, show that the area of the triangular cross-section. So let's go back to the diagram. We're talking about that triangular cross-section. A cross-section is the uniform shape that exists throughout. So for example, here is the uniform shape that exists throughout that triangular thing. You would see it at one end, and it's like it walks itself along the diagram to the other end. All right, so that is the cross-section. The triangular shape that you're looking at is the shape that exists. It's like thinking about a church top, or if I could turn the diagram in another way for you, what if I turn it like this? And you're seeing a church top. You know those type of buildings, look at this. This is the same thing, you just that they turn it another way on you. This is what they have there. So I want you to see that this is what you're looking at from another angle, so you can appreciate what I'm saying. This is the triangle at the front, and it exists throughout so that you see it ending up at the back. When you have that sort of idea, That's what we call a cross section. It exists throughout the shape. All right. So what the question says here is that we want to show that the area of the cross section, is equal to pi root 3 over 4 a square. All you have to do is to take the triangle apart, which is this that you're looking at. Remember that we know what the height is. And the area of a triangle, remember, the area of a triangle is half base times height. Let's go back down here to work it down here. Let me put a little diagram on the side here. All right. Now, height, base is A, height H was given as the root of 3 over 2A. Remember though that they're asking us at this moment to find the area. Let me cross this off. They're asking us to find the area of that triangle. Remember, they did say in terms of A. So here is the idea. Area of triangle is equal to half base times height. Now, half base is A, times height, and the height is root 3 over 2A. Base times height. Let's simplify. At the top, you're looking at A times A. So you'll have the root of 3 with A square at the top. Because when this A multiplied by that A, you end up with A square. At the bottom, you're going to realize that you have 2 times 2. There is your 4. This is all they ask us to show them. That you will get the root of 3 over 4 beside A square. Question says, determine in terms of A, the volume of the container. Simplify your answer. What is volume? All right. So we're saying that, yes. So look at it. That is what volume is. Area of cross section times height or length. Now we just got the cross section. We were told that the cross section is the triangle. And so the cross section, we could put it here. So the cross section area was worked out just now. Yeah, we just worked it out. And we got the root of 3 over 4A squared. So it's right on top here. Root of 3 over 4. They did say cross section, right? So then all we're going to do now is to apply this. And we have the height. Remember, the height is given from the beginning as 3A. So let's go again. Height of the container is 3A. The cross section of the container is 3 over 4 A squared. So you're just going to multiply these. Let me rewrite it for us. So the volume is the area of the cross section, which is the same thing. And you multiply that by the height, which is 3A. There it is. So this is straightforward. You'll have 3 root of 3. And you'll have A to the third power because you have 2A squared with another A. And this is over 4 right there. That's it. That's the volume right there. So the D part of the question says, given that A equals 10. So now they're giving us a value for A. Calculate the depth of oil in the container when John pours 800 cm cube of oil in it. All right. See if you can understand the concept of volume. So volume is actually, I could use a cylinder, is the area of the base and how far that same area goes. That's what volume is. So then if I can calculate this area down there, I'm just giving you in terms of a cylinder. And then if I can work out how far it goes, then I would have got what is called the space that it is taking up, which is called volume. So volume is actually the space the thing is taking up, where you need the area of what is called the cross section, and then how far it goes with that cross section until you see it at the top, you take up all of that space. That is what volume is, right? Now, what they're suggesting is that for this container now, all right, yeah, something like this. So the container stay like that. Now I'm saying to you that they throw some gasoline in this, or whatever oil I said. So the oil would have obviously come up like this, and you full up the bottom, full up the thing, come up to there. So I'm trying to get you to see what I'm saying. So this is the thing that is poured in it. So it would have had its height when it threw it in there. If it did not full up the entire thing, it's going to come up in the container to a certain dimension. So that's what they are saying to you, that this 800 here would have come up in the container. So in here you have 800 cm cube of oil, and then it would have had some height that we don't know yet. So you throw it in there, it would have risen up in the thing to a certain height. So that's what they're asking you to find. Calculate the depth. Depth would have been how far it would be from, say if it's measuring from here to down here, depth, same thing as the height. This that we get here is the volume of water that went into the thing. Volume is always calculated by the area of the cross section, and you multiply that by your height or the depth or length. So that is the general idea of volume. I'm suggesting that if you really look at it, think about this. The volume of water that you're dealing with is 800. Put it where volume is. This is equal to the cross section. Is a triangular cross section down there. And see it there? Triangular cross section. Yes. So what I'm suggesting is don't stress it. What is the area of the triangle? Root of 3 over 4 a square. And you multiply this by the height. In this case, we could call it the depth, right? Because question is about the depth. So it's the same thing as height. So I'm just using the word. See there? So technically, when you understand, you're saying, but I know everything except the depth. Am I able to find? Yes. Yes. Because all we have to do is to divide. All we have to do is to divide, right? We're going to have to divide, but we got something here. We got a value for A. So we want to rewrite this using the value of A. So A square, yeah? A square means A times A, which will mean 10 times 10, which is 100. So we're going to be using 100 for A square. So let us look at it. So we actually have 800, which is equal to the root of 3 over 4 times 100. And this will times the depth. Remember now, I just substituted A as 10 so that you could see where the 100 came from. But we can do some canceling. Technically, I can do some canceling now, and I will do so. 4 into itself one time, 4 into the 100, that's 25 times. So technically, this is what we have. We have 800, which is equal to, you can say 25 root 3 times the depth. Working math all the way down. So all we're going to do now is to divide both sides by 25 root 3, and the answer will come out. 25 root 3. It will cancel itself on the right side. So you could see now that we have the depth alone on the right side. I'll highlight it. We have the depth alone is going to equal to whatever number we get here. You could work out that on your calculator. 800 divided by, you could put it in a bracket so you don't make any error, 25 root 3. And the answer is that the depth is going to equal to 18.47. I could say 18.5 centimeters. All right, there's a E part to it, and it says the diagram below shows the net of the container when it is opened. We're seeing here we have the net, yeah, of the container. So they cut along the edges and they open it out for you. What is the question focusing on in this? Show. So the question is saying, guess what? Show that the area of the net in terms of A, it is still in terms of A. Show that the area of the net in terms of A is half A squared, open bracket 18 plus the root of 3. And they are suggesting that that has the same meaning as this. I don't think it's a lot of mark for it then. 2 marks. So they are saying that, hey, you could put this together, right? Let's go back to some labeling. I'm going to label for us. The side of this was 3A. That means this is 3A. And all of these would have been A and A and A and A and A and A, and this is A, and this is A, this is A, this is A. Because the question did say that and this is 3A, this is 3A. So you're seeing 3 rectangles and 2 triangles. But I think I'm going to wrap up this kind of easier than normal, because we have found some things already, right? We have found some things already. We already know the area for this, which means that we already know the area for this. Yeah, we found that already. You could go back to the question. It's a cross section. So the area of it is 4 root of 3 over 4 A squared. So basically, we're suggesting that we know some things. This, the area of this is the root. Let me change the marker. All right. So it's the root of 3 over 4 A squared. Over here is the same thing. The root of 3 over 4 A squared. We have those already. So all we need to do now is to find the area of all of this. But you see, sometimes when if you look on the thing holistically, you could go through quicker because the question gave a quick clue. Question says here that, where it is? show the area into. You see here? It says hint. It's giving you a hint. That means when I saw the hint, I'm like, I'm not going to work this out long. I'm just going to work with the square. A, B, C, D is a square. They're telling us that, guys, note that A, B, C, D is a square. You see what's going on, people? This is a square, which means I am not going to find the rectangles 1, 1. I don't need to find them 1, 1. They just told me that this shape is a square. And one side is 3A. One side is 3A. We spoke about that already. It's labeled on it. And if one side is 3A, I can easily find that area. So that's what we have. So it is a square. So if one side is 3A, it means that the length of this side, yeah, is also 3A. And you see it for yourself. A plus A plus A is 3A. So yeah, you're seeing it. That means I'm able to find that green part easily right now. Let's go for it. Now, the square. So basically, I'm finding the area of the square. Area of square plus area of 2 triangles, and we would have found the area of all of that. Now, the area of the square is going to be 3A times 3A, because the area of a square is one side times the other side, length times length. And then now I have that. I have 2 times root 3 over 4A squared. So here it is. This part is representing the area of the square. And this part is representing the area of 2 triangles. We're done. Put it together now. This becomes 9A squared. But I would want to cancel now because I like work simple. I would like to cancel 2 into itself 1 and 2 into the 4, 2 under the bottom there. So basically, this is where I'm at. I have plus, and this is like so this is like half, but I'm just going to put it like this. Root 3 over 2A squared. Now, we actually have the answer, right? We actually have the answer. You want to represent it like how they give it to you like this, then you need, everything is there now. Imagine that I factorize out the A. I'm trying to get you to see it in style, in pieces. Factorize out the A square. You would have A square, open bracket, I'm just saying there is a 9 plus root of 3 over 2. I'm just showing you how we just minimize it, and it's like, okay, you're seeing it shaping out. Now, I want you to think about this. I want you to think about this. If I take this part inside here and operate on it using fraction, because I want it to look like this, you know, that's all. I want it to look like that. So if I take that part, so let me put it up here. I'm going to work it out somewhere else, like right up here. If I take out that part and I have 9 over 1 plus the root of 3 over 2, the LCM is 2. 1 into 2, 2 times. 2 times 9, there goes my 18. 2 into itself, 1 time. 1 times the root of 3, there goes my root of 3. Oh, let me rewrite this then. We have A squared. This is what I have in bracket now. 18 plus the root of 3, but all of it is over 2. Now, you can see you're almost there. Over 2 means a half. So I could take that 2 outside and go all the way out front. What do I mean? This is a half. So then it means that I could actually take it out and put the half all the way out there. Put back the A squared. And in the bracket, you will see 18 plus the root of 3. And you would have given it just like this. that they had said. And you're done.